All right, my friends, let's look at 2007 Form B, problem 6. Last problem from the review packet 4, and then you get to put that thing to bed. It says, let f be the function given by f of x equaling 6 times e to the negative x over 3 for all x. For part A, they want us to find the first 4 non-zero terms and the general term for the Taylor series for f about x equals 0. There's more than one way to do part A. You could start from the definition of a Taylor series centered at 0, take, all the derivatives that you need and build it from scratch. That is going to take more time than what I want to do. So instead, I'm going to use the idea of knowing the power series for e to the x, knowing that expansion, and then building this expression up using substitution and multiplication on that parent function. If you've forgotten the power series expansion for e to the x, then I recommend going back, studying that, and studying sine of x and cosine of x. You will be so happy with yourself if you have those three in your back pocket when you go into your AP exam. It really does save a lot of time. So for example, for part A, I would start with, hey, what's the Taylor polynomial for e to the x? And it's just really nice to just know it. If you forget it, you can always build it from scratch. So that's the first 4 non-zero terms, and then we'll need a general term. So you could just notice that this is x to a power divided by whatever number's here. That's the type of factorial that's on the bottom. And this would work for a general term. A comment, and you do not need to write what I'm about to write here, but the way that I've got this set up, if this is my expression for the general term, then this would be like my 0 term, and this would be my first, and then this would be my second term. So the reason that my pattern makes sense is because it would be representing this, this expression. Another correct answer, just as correct, would be to have x to the n minus 1 over n minus 1 factorial. And then that answer would have an initial value of 1, and they're both equally correct. I'm just going to use this one because it ends up being easier to work with in the long run. Now let's substitute and get an expression for e to the negative x over 3. And then you can even substitute into that general term. And you don't need the sigma expression, but you could get it just by substituting in negative x over 3 and for x. So now I'm going to go ahead and simplify it. Okay, so this term would be positive. It would be x squared. I'm going to write it like this, 2 factorial over 3 squared. The next term would be negative x cubed over 3 factorial times 3 cubed, and so on. I'm going to simplify the general term as well. You don't have to, but if you did, it could look like this. Like that. And then that would be your expression for e to the negative x over 3. Okay, one more thing. To build it up to f of x, we would need to multiply both sides by 6. So let's do that. So you could just kind of show that you would distribute the 6 in. Don't forget that plus dot dot dot. Or you could distribute the 6 in, and I think I'm going to be happier with distributing the 6 in. So let's do that. So you'd have 6 minus. The 6 and the 3 cancel here. The 6 and one of the 3's and the 2 factorial cancel here. 6 and the 3 factorial cancel, so you'd be left with 3 cubed or 27. And then on the general term, I would just show it as 6 times negative 1 to the n times x to the n over n factorial times 3 to the n. Don't forget the plus dot dot dot. And then what would this expression be equal to? You could say 6 times e to the negative x over 3, but for future parts in the problem, it's probably going to be a little more helpful to just say it equals f of x. There we go. Okay, part B. Let g be the function given by g of x equals the integral from 0 to x of f of t dt. Find the first 4 non-zero terms and the general term for the Taylor series for g about x equals 0. So I'm going to think of this integral as the antiderivative of f with the upper bound plugged in, take away the antiderivative of f with the lower bound plugged in. Now I'm going to figure out what this antiderivative would be first. So antiderivative of f with respect to x, which is why it's kind of nice that I labeled this the way I did. You can see you're just going to do antiderivative term by term. You would also have a constant of integration. So I'll just go ahead and put c plus and then start doing antiderivatives. Term by term. X to the 4th over whatever 4 times 27 is. Okay, now let's talk about doing antiderivative with respect to x of this general term here. Notice that the only piece on this term that actually has x in it is x to the n. The rest of the stuff, as far as your antiderivative is concerned, is a constant multiple. So you're basically going to do this constant multiple times the antiderivative of x to the n, which would be x to the n plus 1 divided by n plus 1. And don't forget your plus dot dot dot. Okay, now from here, let's figure out what this piece would be, the antiderivative with 0 plugged in. Well, you just take all the x's and replace them with zeros. So what would happen to all the terms that have x's in them, which is all the terms except this little front one? Well, they would all go to 0. So what would big F of 0 be? It would just be that constant of integration. Now, what do I need to do between these two expressions to get this one and hence this integral right here? I just need to subtract them. So what would I then have? Big F of x minus big F of 0, that's the integral from 0 to x of f of t dt. And what would I get on the right side? The c's would cancel out, or would vanish essentially, and you'd end up with just the x terms. All right, and you're welcome to leave 4 times 27 the way it is. I do think it's 80 plus 28, so 108. But it's okay to leave it as 4 times 27 as well. Now I'm going to simplify this down just a little bit. The only place where I can see some room for some simplifying that would be make it a lot cuter is the n factorial times n plus 1. That could be said in a little bit of a simpler way. So n factorial times n plus 1 is n plus 1 factorial. There we go. Okay, and then that is your answer for part B. Okay, now for part C. Okay, part C says the function h satisfies h of x equaling k times f prime of ax for all x, where a and k are constants. The Taylor series for h about x equals 0 is given here. Find the values of a and k. There is more than one way to do this problem. I'm going to show you my way. You're going to see me build up this expression right here using the fact that this is f. you're going to see me find f prime first, then you're going to see me substitute ax in, then you're going to see me multiply it by k. After we build it up, we're going to set it equal to h of x, which is given here, and it's going to fall into place really nicely. So let's get started on that. So if this is f right here, then what would f prime of x be? Well, derivative of 6 is 0. Derivative of negative 2x is negative 2. Let's see, derivative, that would be 2/3 x minus x squared over 9, and so on. And we won't need the general term for this part. Now let's figure out, well, what would f prime of ax be? It would just mean all the x's got replaced with ax. So we'd have negative 2 plus 2/3 ax minus, and you'd have ax quantity squared, which would give you a squared x squared, like so. Now let's multiply both sides by k. So you'd have k times f prime of ax. That would equal negative 2k plus 2/3 akx minus a squared kx squared over 9, and so on. Okay, now they did say, I'm going to say since h of x was supposed to equal this expression that I just built up, k times f prime of ax. Well, what would that mean? If they're the same, then that means that their constant terms should match, and their number of x to the first power should match, and their number of x squareds should match. So let's look. So what's our constant term for this expression? It's negative 2k. And what's the constant term for h of x? It's 1. Well, if these two polynomials are equal, then that would mean that negative 2k here would have to equal the 1 from h of x. And then little algebra 1, and you know what k is. So k would be negative 1/2. So there's your value for k. And again, if h of x and this polynomial are exactly equal, then the number of x to the first powers, which would be 2/3 ak, would have to equal the number of x to the first powers over here, which is just 1. So that means that 2/3 ak would have to equal 1. And then we found that k is negative 1/2, so you'd have 2/3 times a times negative 1/2 has to be 1. And then the 2's cancel, so you're left with negative 1/3 times a has to be 1. So what does that mean? That would mean a is negative 3. There we go. All right, my friends, I hope this is helpful to you, and I hope you're having a great day. Take care, everybody.